Well, hello, computer nerds, electronics geeks, YouTubers of all sorts. Welcome back to my channel. And this is episode 9. 9. I actually had to go and look at what last episode I put up was because I'm losing count here. But episode 9 of me trying to get this Teletek Systemaster single board Z80 computer, S-100 computer, up and running again. Now, in the last episode, I had pretty much given up on getting the virtual floppy to load, at least for now. I haven't totally given up. I'll keep working on it. What I did start doing was writing my own firmware and exercising the board with my own firmware by replacing the EEPROM in here with an EEPROM that I had loaded with my own files. And I was doing some interesting stuff. And I've come a little longer way with this, getting better and better at it. Now, one thing I wanted to show you here was I wrote a memory test program, just a little quick and dirty memory test program. By default, the Systemaster comes up with the RAM out of the circuit. It is not enabled. So only the ROM is enabled. So there's an onboard register which you have to write to at one of the output ports. And you've got all kinds of options in that register. You can have the ROM on, the ROM off, the RAM on, the RAM off. So I had to figure out in the manual, and this is one area where the manual seems to actually get it right. Figure out what I had to write to that output port to turn the RAM on and leave the ROM on. I wanted to leave the ROM on so that I could execute my program out of ROM. And then I wrote a little memory test program, put it in ROM, and run it just to make sure that A, I got the RAM turned on. I actually did that. And B, the RAM is any good. So here's a little program. I'll start it up. And the only output I have is these LEDs over here. But it's working. It's counting down from high memory. It's testing the RAM as it goes. It's writing 5.5 to it and then reading back 5.5 because 5.5 is alternating ones and zeros. Then it reads AA to it, which is alternating ones and zeros again, but opposite. And as long as it reads back what it wrote into the RAM, everything's hunky-dory. It keeps going. If it hit a problem, it would stop and put out a certain pattern on the LEDs. But it went through the entire RAM. Only the last one's on. That's my indication that the RAM is good. So the RAM is on. The RAM is good. So that's great. So that means I can start writing much more complicated programs in my EEPROMs here. I can set up a stack. I can have subroutines that are called and returned because I've got a stack now to put the program counter and other variables on. So I can start writing much more complicated programs. So that's really good. I can really start exercising this thing. Maybe even get a real monitor program into it. So yeah, so let me reset it again and here we go. We'll just count through the memory again. It's actually a fairly fast memory test. So it checks all of the RAM outside of the ROM area. So everything seems to be hunky-dory. Now actually, one thing you can do with this is you can actually write to the RAM that overlays the ROM area. Because you got 64K of RAM here. So you can actually write to the area of RAM that occupies the same space as the ROM. You just can't read from it. But what that allows you to do is copy the ROM into memory, and then you can turn the ROM off, and then just execute entirely out of RAM, and have 64K of contiguous RAM space. So that's one kind of neat little feature of this board. I think that's something that's required if you're running CP/M, or at least certain versions of CP/M. So okay, so we got good RAM, so that's good. Okay, I was talking in the last video about, speaking of EEPROMs and EEPROMs, about the need to get a larger EEPROM in here. I mean, this is 2K by 8. That's, most of the monitors I want to run on this are like 8K. you know, and if you want something like basic, you need more space still. So I've been wanting to use a larger ROM or EEPROM in here. And I talked last time about how they say in the manual that there are jumpers you can configure to change that. Well, there's jumpers over here and there's jumpers over here that you need to change. Well, the jumpers don't exist on the board. There are no jumpers. Well, I've got a clarification on that. I was actually looking at the manual for the Systemaster 2, which was the successor to this board. And in the manual to the Systemaster 2, they go into a little more detail. There are no jumpers. What there are pads and traces on the board that you either need to cut or solder bodge wires across. Boy, you had to really be hands-on back in the day to get your computer up and running, didn't you? I mean, geez, guys, how about some jumpers? How about some dip switches? You know, traces and trace cutting and bodge wires. I mean, really, come on. And they're on the back of the board, which is why I couldn't find them. They're on the back. So I have to disconnect everything, take the board out, and then I can see the traces that need to be cut and the pads where bodge wires need to be soldered across. Okay, I can do that. I can do that. The problem is I want to keep this thing original. I don't really want to do that to it. I don't want to mangle it. I want to keep it original. I guess I could always put it back the way it was, but it was still, it would have been modified. So, not sure what I'm going to do about that. Of course, what I could do is just write some sort of little bootloader program that'll fit in the 2K I've got available here. Load stuff into memory and then turn off the EEPROM, and that's really the way it was meant to work. You just got a little bootloader in here. It would load the operating system, you know, off of disk, and then it would just, you know, take the EEPROM out of memory. So that's the way it was designed. So that's probably what I will have to do, unless I want to, you know, get the soldering iron and the X-Acto knife out and start cutting traces and soldering on bodge wires, which I really don't want to do. So, okay, so anyway, I got the memory up and running, so that's good. So that means I can start writing some more complicated programs, including testing out the serial connection. I think I will do that next. Okay, that took a little while, and the sun has shifted, so I don't know if you'll be able to see the LEDs over here or not anymore. Got some wicked sunlight coming in. But I wrote a quick and dirty program to just output to serial port B over here, and I've got my terminal program on my laptop hooked up to it so we can see what comes out. So it's, like I said, a quick and dirty program. I'm using a delay. I need to, now that I can turn the memory on and set the stack pointer and all, I should be able to write actual routines. So the next iteration of this, I'm going to write some proper get care and put care routines and poll the registers in the SIO and see if it's ready for the next character, or if it's waiting, if it's got a character waiting from the input. So right now I'm just outputting to the terminal with a time delay, just to make sure that there's enough time between the characters so they don't overrun each other. I'm also echoing the character out to these LEDs just so I know something's going on in case I don't get anything on the terminal, which has helped a lot with troubleshooting. You know, interestingly, I had a dream, a bad dream back when I was in college and I was learning computer science and programming. And I dreamt that I had this incredibly sophisticated computer that I was working with, but the only output it had was 4 LEDs. And I had to interpret everything it was trying to tell me through those 4 LEDs, and it was very frustrating. Here I've got 8 LEDs. It's still frustrating, but believe me, it's better than nothing. You got some kind of output. You know that your program's running. I can echo stuff to the parallel port and say, okay, it's coming out the parallel port. Why is it not coming out the serial port? And you can troubleshoot it. But everything seems to be working. So let's fire it up and see what we get. Not much to see here. And I don't know if that's showing up. It's just a pattern of alternating ones and zeros there. And what that is We zoom in up here. Oops. I hope that's showing up. If it'll focus. It's just writing U to the screen. See if I can get the focus a little better here. I guess it's about as zoomed in as I can get. Yeah, so it's just writing capital U's out to the screen, and I kind of chose capital U more or less at random just because, you know, it would make that alternating pattern of ones and zeros on the LEDs at the parallel port there, so I know it's writing what it's supposed to write. So we're getting output from the serial port, so that's a beautiful thing. The serial port's working. I had to do, it takes a lot to get the serial port working, let me tell you. First you got to program up the counter timer chip so you get the proper baud rate. And here's the counter timer chip right here. So, and I was checking with my oscilloscope over here to make sure that it was actually putting out the right baud rate to the input of the SIO. And then you've got to program the prescaler in the SIO. And you've got to program a bunch of registers in the SIO. And then you can actually read and write something to the serial port. There's a lot of moving parts involved in that. The SIO chip is very complicated. I've seen some other much less complicated UARTs out there. And the Z80 SIO, it's kind of a bit of a Rube Goldberg machine. There's a lot of moving parts in there. But it seems like I've got it to where at least I can output. So that is a start. So for my next trick, I'm going to write proper get care, put care routines and see if we can do some more useful input output through the serial port here. So we're sort of, you know, learning to crawl before we can walk and walk before we can run, but we're slowly getting there. Things are happening. So let me go back and do some more programming. Maybe I can get that done and tuck it in at the end of this video, hopefully. All right. It's been another little while, and I have been furiously coding and debugging. Check this out. Let me move the camera a bit and give you a better view of the computer screen than what you've been getting up till now. Get it focused really good here. Focused. And then let me turn on the Systemaster. Don't make a liar out of me. Work like you did before. And we get garbage. Let me hit the reset button. This doesn't always work when I turn it on, but I've hit the reset button. Ah, there we go. There we go. Systemaster up, awaiting instructions. Well, it's not really waiting instructions. I just had it print this out. I got my get care, put care going, and I'm having it output a couple of lines of text there. And from now on, it's just going to echo back anything I type at the keyboard here. So that's all it's doing. It's just echoing it back as I type. So, you know, some uppercase there too. Yep, it's all working good. So not only is it echoing it to the screen whenever I type stuff, it's echoing it to the LEDs down there on the port. Basically, I echo anything that goes to put care out to the port too, the parallel port, just for troubleshooting purposes. So, hey, this has been a productive day. I got the serial, I got the memory working first off, and now I can write decent programs. Now that I've got a stack, I can write subroutines basically. So call and return is a beautiful thing. No more spaghetti code. So yeah, and I got the serial port working. So this is great. I'm making good progress on this. This has been a very productive day. So I need to see if I can either find a small monitor that'll fit into 2K or write something. Hey, I've got get care and put care. I'm well on my way to having my own monitor, minimal monitor going here. I suppose. So we'll see. We'll see where I get by episode 10. What I've got going on with this thing. But I think today's been a very good day, and I hope you found my work on this interesting. Give the video a thumbs up if so, give it a like, and subscribe to see future videos. There will be more videos on this. There'll be more videos on other aspects of retro computing. I got a couple other projects going on, my breadboard computer and the ET3400 I bought recently that needs a lot of work. So there'll be videos coming out on those. And thanks again for watching. Subscribe, press the little bell icon, and I'll see you next time. Bye.